In question 2, we have a diagram of a ball rolling in a frictionless track with zero air resistance. In A, we're told Galileo thought that the ball would reach position C if released from position A at rest, position C being the same height above the ground as A. We need to use ideas about energy to explain why he was correct. Well, in the absence of friction or air resistance, no energy would be lost from the system, so the initial gravitational potential energy would all become kinetic energy at point B, the lowest point, then would become the same amount of gravitational potential energy at C, which, as the mass is constant, means it will have to be at the same height as A. In B, we then have a track which starts off as a slope and then becomes flat. We need to add to these axes a graph to show how the speed of the ball would vary with time, indicating at point B where the ball reaches the flat part of the track. Well, initially the track is steep, so the ball would accelerate rapidly. The acceleration would reduce and would be 0 from point B, something like this. In C, Newton published his 3 laws of motion later than this. We need to explain how Newton's first law of motion is shown by the motion of the ball between B and X. Well, between B and X there is 0 resultant force. Well, between B and X there is 0 resultant force and the ball is travelling in a straight line at a constant speed.